In this first video lesson, we're going to be learning about linear systems. Specifically, we're going to learn 3 different methods that can be used to find the solution or a point that satisfies a pair of linear equations. You can find my lecture outline on D2L. It's basically the same document you're seeing on the screen. This is going to be your lecture notes for the course, and so I want you to take notes on how to complete these lecture examples. You'll be submitting your notes on D2L. At times, I might move through things pretty quickly. Feel free to pause the video. You can always send me an email if something's unclear to you as well. So let's get started. In my first example, we want to determine if the point -2, 1 is a solution to the system. It's basically asking us if we plug those numbers in, do we get a true statement? So we'll start by plugging in -2 for x and 1 for y in the first equation. -2 minus 3 equals -5. Yes, that's a true statement. However, if we plug those numbers in to the second equation, 2 times -2 is -4 plus 1. That's -3. That is not equal to 4. Because this point doesn't satisfy both equations, it is not a solution to the system. So to summarize, a point has to satisfy both equations to be a solution. Now, how do we find solutions to linear systems? Well, a linear system is basically 2 equations of lines, 2 linear equations. So one method we can use is the method of graphing. We can actually graph each of these lines and then visually figure out what point satisfies or lies on both lines. So first, a very fast review. If we put the equation of a line in slope-intercept form, so solve it for y, then the m, the number in front of the x, is the slope, and the b, the constant, is the y-intercept. We're going to use that fact to graph these lines. Let's start with the first one, 3x plus y equals 4. To put in slope-intercept form, I subtract the 3x. Y equals -3x plus 4. So the slope, the number in front of the x, is -3, or -3 over 1. We're going to recall that slope is rise over run, or change in y over change in x. We'll use that in our graph. The constant, or the b, is 4. I'm going to start by plotting a point at y equals 4. That's my y-intercept. Then I use my slope to go down 3, rise -3, and to the right, run +1. I can repeat this process a few times, and once I have enough points, I'm going to connect the dots and create a graph of that first line. So in red, I've graphed the first line. Now let's do the exact same thing with the second line given. To put in slope-intercept form, we're going to solve for y. So that means I'm going to start by subtracting the 2x. Then I can divide everything by -4. And that gives me y equals 1/2 x plus 1/2. This time, both the slope and the y-intercept are 1/2. I'll start by estimating where y equals 1/2 is for that y-intercept. And then I have to go up 1 over 2, rise over run, 1 over 2, to get a couple points on that line. Finally, I connect the dots, and in green is my second line. To finish, the solution is the point that lies on both lines. In other words, I read the point where they cross. In this case, they cross at x equals 1, y equals 1, and so that's my solution. Now there's 3 different things that might happen when you're solving a linear system. The first thing that happens most frequently, what happened in the last example we just did, is the 2 lines will cross at exactly 1 point. That's going to happen anytime you have different slopes. Different slopes lead to one solution. However, if you have 2 parallel lines, as shown in case 2, the lines never cross. Parallel lines have the same slope. So lines with the same slope will have no solution. Finally, it's possible that the lines could be identical, same slope and same y-intercept. In that case, there's actually an infinite number of solutions. Every single point on that line is actually an intersection point. Now, we don't want to have to graph a system every time we want to find its solution, so we're going to learn two non-graphing methods. The first one is called substitution. In this method, we're going to take one of the equations and solve it for one variable. Then we're going to take that expression and plug it into the other equation. So let me show you how this works. I'm going to start with the first equation. 3x plus y equals 3. I'm going to solve this equation for y, and I can do that by subtracting the 3x. So y equals negative 3x plus 3. Note, if there's a variable that doesn't have a number in front of it, if there's a variable with a coefficient of 1, that's the variable you want to solve for. It'll make the problem easier in the sense that you won't have fractions to deal with. So in this case, I chose to solve for the y because it had a coefficient of 1. There was not a number in front of it. Now I'm going to take that expression for y, and I'm going to plug it into the second equation. This is now something we can solve. Get rid of parentheses, combine like terms. Let's see, get x by itself, so subtract the 6. Divide by negative 9. So x equals negative 3 divided by negative 9, which is 1/3. Now my solution is an ordered pair, an x and a y, an intersection point. So I'm going to take that 1/3, and I'm going to plug it into my equation, y equals negative 3x plus 3. Negative 3 times 1/3 is negative 1, plus 3 is 2. So my solution is 1/3 2. X is 1/3, y is 2. Now in this third method I'm going to show you, called elimination, we're actually going to take our equations and add them together. More specifically, we're going to add multiples of the equations together with the goal of eliminating or canceling out one of the variables. So let's say I want to cancel out the x's. I want to get rid of the x's. I notice that if I multiply the top equation by 2, that term becomes 6x. If I multiply the bottom equation by negative 3, I get a negative 6x, equal but opposite coefficients. So I multiply every term in that first equation by 2, every term in that second equation by negative 3. And now when I add the equations together, I get negative 14y equals 1. This is something we can solve. We can divide both sides by negative 14, so y equals negative 1/14. Now I can take that number and plug it into either equation to solve for x. But if I want to avoid dealing with that fraction, I can actually start over and use elimination again, but this time eliminating the y's. Let's do that. So if I want the y's to have equal but opposite coefficients, I just need to multiply the bottom equation by 2. That'll give me a positive 4y. Top equation stays the same. Bottom equation gets multiplied by 2. So now when I add these things together, the y's disappear, and I'm left with 7x equals 11. To solve, I divide by 7, and there's my solution. X is 11/7, y is negative 1/14. So those are our three methods: graphing, substitution, elimination. Make sure that you read the directions in your homework carefully, as exams might tell you which method to use. Now let's do one more example. Now if we want to solve equations with fractions, any equations, we can actually get rid of the fractions by multiplying every term by the LCD. That first equation has denominators of 3 and 5, and so the LCD is a number that can be divided by both 3 and 5. In this case, the LCD is 15. So I'm going to multiply every single term by 15. That gives me 15x over 3 15y over 5, and whatever 7 times 15 is. Well, 15 over 3 reduces to 5, 15 over 5 reduces to 3, and 7 times 15 is 105. That's my first equation. Now let's do the same thing to the second equation. This time the LCD is 30. 30 is divisible by both 6 and 5. And 30 divided by 6 is 5. 60 over 5 is 12. 4 times 30 is negative 120. Now I've got two equations, neither with fractions. So now we get to choose substitution or elimination. I'm going to use elimination because I notice both equations have a 5x. And so if I multiply the second equation by negative 1, now I have a negative 5x, equal but opposite coefficients. So if I add those two equations, the 5x's go away. 15y equals 225. Divide by 15. And 225 divided by 15 is 15. So now I'm going to take that 15, plug it into any one of the equations on my paper. I'm going to choose the one in red. 5x plus 3y equals 105. I'm going to plug in 15 for y. 5x plus 45 equals 105. Subtract the 45, divide by 5, and I get x equal 12. And there's my solution. X is 12, y is 15. Once you've gotten these notes taken down, you are ready to go into my math lab and try that first homework cassette. Please let me know if you have any questions. I know this is a lot of content, and I'm happy to go over some more of these problems with you either during office hours, or I might be able to help you over email. Once you complete the My Math Lab homework, then you're ready to try the Quiz Yourself worksheet. See if you can do some of these problems on paper, and you'll submit that worksheet on D2L. So, as always, please shoot me an email if you have any questions.